Hey class, here are the lesson notes for lesson 3.2 linear functions. This was our opener. We did this on Canvas. You'll look at each of these two pictures and you'll figure out what are the math fails each one has and you'll post it in there. Learning targets for the day are right here. Please write down all three of these. So you should be writing down this one, and this one. Pause this video before you move on so you can get these all written out. Alright, here's some key notes for today. Just a big concept of the difference between a linear function and a nonlinear function. So linear functions have a constant rate of change and they're represented by a linear equation with two variables, meaning that linear functions are y equals mx plus b. Nonlinear functions do not have a constant rate of change, so graphs are not lines. So they might be more like curves or U-shapes or something else. But a linear function is going to have a straight line graph, and it's going to be represented by that nice y equals mx plus b equation. So looking at these ones, remember that to be a linear equation, they must form a line, meaning that it's not curved at all. Therefore, this one on the left is not a linear equation, whereas this one on the right is a linear equation, or linear function. And that's how we would see this graphically. As we look at tables, we want to see if it is changing at the same rate. So the way to do this one is to look at and see what is the change as you go from each piece to the next piece. So here we have a +3, +3, and a +3 for our changes in x. And our changes in y's are always -6, -6, -6. Notice how these change at the same time each time and the same amount. Therefore, this one is linear. Okay. For the next one, we do the same process. So our x values are all changing by +2, which is a good thing. So those are all consistent. However, our lower ones, first it changes by 7, then it changes by 11, and then it changes by 15. You'll notice that these are not constant, 2 to 7, 2 to 11, 2 to 15. So this one is non-linear. It's still increasing, but it's not a linear function. Alright, probably the hardest one here is when you're just looking at equations. So let's keep something in mind. To be a linear function, it must satisfy the idea of y equals mx plus b, where it has a slope and it has a y-intercept. So as we look through these ones, our first one would be. So this one would be. Our next one has a square root sign, therefore it does not. Square roots are not linear. The third one, 3 to the x, we'll notice how our base equation doesn't have any exponents of a variable, so therefore this one's not correct. Y equals 2 divided by x is also a non-linear function. You can check all these on Desmos as well. For this one, y equals 6x minus 1, you could distribute this. This would become y equals 6x minus 6, therefore that one would be. And same thing here, there are no exponents in a linear function, so right away this last one does not work. So if you see anything with exponents or square roots or possibly dividing the x value on the bottom of a fraction, those ones are not going to be. But these other ones would be. Alright, just as a key summary, so a linear function would have words that are written out, something like this. It could have an equation modeled in mx plus b. You could make an input-output table for it. You could do a mapping diagram, and you'd have a constant line graph. So now we're going to move into a next part, which is still very important. Solutions of linear equations are often given in two variables, like an xy pair, which means you have to have both the x and the y true. However, they can come in two different forms, so make sure you write these out. The first one is a discrete form. So discrete means it's only certain numbers, whereas a continuous means it's all of the numbers within that range. So we're going to look at some word problems and we're going to break it apart. This example will go over a couple different pages. So this one here gives us a linear function of 15.95x. So that could be like, a sweatshirt costs $15.95 per sweatshirt. In this case, they're talking about tickets for museums, actually. So let's use that. So this is, tickets to get into a museum is $15.95 for each ticket. Each customer can buy a max of 4 tickets. So the domain, remember, domain is input. So is it discrete or continuous? Well, this would be discrete because you only can buy 0, 1, 2, 3, or 4. You cannot buy a half of a ticket. You can't just go to part of a museum. You have to buy the ticket for all of it. So that makes this one discrete. When you want to graph something, use an input-output table. So you'll have your inputs, you'll have your outputs, modeled by whatever is your function. So your functions go here, and then it creates your ordered pairs in the end. Once you've gotten enough of all the ordered pairs, and you've run all of your inputs through your function, getting your outputs, you can then graph those on a graph. Notice how this graph does not include a line, it is just points because it is discrete. Alright, so another example is, you're eating cereal bars, so maybe you're eating like those Fruity Pebble bars or those Captain Crunch bars you might see at Hy-Vee or at Cub. So the number of calories consumed is a function of the bars eaten. This should make sense then. For every bar you eat, you have so many calories. So this is actually a linear function because for every bar you eat, you're going to have more calories, and it's the same amount. However, you can eat just part of a bar, so it's possible to bite off just a little bit of it, or half of it, or split it with a friend or a sibling. So therefore, once you start eating, it can be more than 0, but it could be anything more than 0. Therefore, it's going to be a continuous function. Again, same thing. When you want to graph, make an input-output table, and do this by using the function. So like we said before, every bar is 130, so you have 2 bars, it's 260 because you're just doubling that, and you're adding 130 each time. This one was continuous, so when you do graph these, you do have to make sure you have a line on this. Alright, last 2. So if you have to write real-life problems, now you're given a graph and you have to write them. So let's first decide discrete or continuous. So the one on the right is our discrete one, and the one on the left is our discrete one, and the one on the right is our continuous one. Again, given by the fact that these are just points and these are lines. If we had to come up with a scenario for these ones, the one on the left, you're having exact values. So think of things where you can't have parts of things. So like oftentimes, if you're thinking about, money is oftentimes a good example. So you could say I started with $6, and every day I spent $1. Therefore, after 6 days, I had $0. So that would be an example of that one. Please write down that example I just spoke out. Then, for this one, you could say something like, I am 6 miles away, and as I walk, I get closer to where I'm going. So you could have more of a distance thing, so that way you're always somewhere on this path. But maybe you say like, how far away I started, how much I've walked since I've started. So obviously the more you walk, the closer it's going to get to. Here's your math homework for this lesson. There is 31 problems. 25 minutes, it might take a little bit longer than that. I might need to cross that out and replace that. But it's okay, you guys have today, tomorrow. You may have started this a little bit early. Just as a reminder, the retakes are on Wednesday. You need to make sure you've met with me, either going over your review or your Chapter 2 corrections, so that way you can do your retake on Wednesday if you need to do a Chapter 2 retake. Have a great day.